All right. So what exactly is a JORC compliant resource and how do I make one? So that might be slightly provocative for a few people in the room. And if not, I will explain why in the next slide. So there's no such thing as a JORC resource. It's a very punchy way to get through with an ASX announcement. And it's not technically wrong, but it is technically wrong. We're going to be technical. So the report can be JORC compliant or in adherence to JORC code. The resource itself cannot. So that's just one misnomer. So how can you create a JORC compliant resource report then? Luckily, it's not just a checklist of requirements. Otherwise, you'd have a lot of trouble. It's more of a spectrum. So you've got to think about it when you're producing your resource report. There's going to be a spectrum of what's considered best practice at one end, and most people would agree, and at the other end, what's not considered best practice, and most people would agree. And lots of room in the middle to debate. So what is JORC trying to achieve? Well, JORC is trying to not be prescriptive, but it's trying to give us some holistic standards to address when we're doing our reporting of our resource. So those are materiality, competency, and transparency. So what we also have helping us out is all of the governing bodies. So we have ASIC, we have Bellman, AusIMM, and AIG, as well as ourselves as peers to make sure that we're all happy with the standards that we're all going to adhere to. But again, if you're confused, I'm not surprised, because what is best practice? You know, you could ask anyone in this room and there'll be slightly different answers, which is a good thing, but it does make it a bit ambiguous. So these are the 3 tenets of the JORC code, and I agree with them, but I think potentially we need to have slight tweaks to them, or at least thinking about different things when you're writing a report or when you're questioning someone's report. So transparency, obviously we need to have transparency, but we need to have transparency with context. We don't, and I'm stolen that from Elizabeth Harris, so we want to avoid word soup. You know, we don't want to just have a whole bunch of, you know, jargon in there and it's transparent, but no one actually knows what you did. We want to have clear visual examples. We're scientists, we want hard evidence. We want to have it nice and clear exactly what's been done. We shouldn't be placing the expectation on the reader to try and figure out what we were assuming at the time. Make it nice and easy for them. Competency, obviously, competency is very important. It's self-determined in our industry, and the premise is that you should be able to stand in front of your peers and defend your work, which I think can come across a bit combative. I think it needs to be more stand in front of your peers and have an open discussion about the reasoning that you've taken and what other options there might be. And we also need to be constantly evolving. We're seeing today, like some of the stuff that Scott had this morning with code reading, which I haven't used in anger, Jonathan, I know I will. But there's some really good technology out there, and we need to be open to exploring it and constantly evolving. And lastly, peer review. Peer review is so important, and I've worked at lots of different places where it wasn't a priority for various reasons. But I think, you know, peer review doesn't have to mean a full audit. You know, it could just be asking a fellow resource geologist, hey, just check my assumptions, give me a sanity check. You know, I've tried something a little bit different, what do you think? Or it could be beta floor analysis, due diligence. You know, it doesn't have to be onerous. And it's a great opportunity to learn from different people and get a different perspective. And materiality. So materiality is obviously very important, but it's not just the final resource, you know, change in ounces at the end of the day. Resource has to be looked at, materiality has to be looked at a compounding errors potentially through the process, as we were learning about today with the fundamental sample error. These things compound, and so we need to be looking at thinking about materiality throughout the whole process. And I think, you know, we all do QA/QC, and I think we need to be thinking about qualifying as well as quantifying these things. So a good example would be, you know, we have a drill hole database. It's potentially historic, 20 years ago or something. We might not have all of the metadata that we would wish. And we'll state in our report we got rid of holes 1, 2, and 3. Okay, that's great. But maybe holes 4 to 10 were fine to include, but maybe they used a slightly different assay technique, or they had a slightly less precise DGPS or something like that. They're still fine to use in the report, but qualifying your confidence in those drill holes and making sure that is present in the database when you do your resource classification is a way of qualifying your confidence in the material changes within the deposit. So how do I make a JORC code compliant resource report? So from my perspective, I read lots and lots of resource reports when I was a junior resource geo at SRK. I would read heaps and heaps, and I had no idea really what was wrong, but some of the things I thought, not really sure about that. So I would go to the principal resource geos and say, look, not sure about this, can you explain why? So the more you read, the better. The more questions you ask, the better. It's also a team effort. So a JORC resource report is huge, not as huge as NI 43-101, but it is huge, and it's a team effort. So you need to be talking to the geos that have been working on the deposit, logging the cores, doing the interpretation perhaps if you haven't as the resource geo, making sure that what they understand as the geology, you are bringing to life as the resource geologist. And equally, you need to be talking to your engineer, who is your client, essentially. You know, are you creating a model that they can use that is representative? So lots of questions everywhere. So question 1. So I've come up with 5 questions, which as a resource geo, you should be asking yourself when you're putting together your report. And if you're not a resource geo, these should be questions you can ask a resource geo and get a clear, concise response, not some, you know, black box magic resource geology jargon. Yeah, anyone should be able to ask these questions to get a decent answer. So the first question is about compositing. So, you know, what compositing methodology has been taken and why? So some examples I've seen, some resource reports, would be something like the composited for one meter down hole, following analysis, and this is the resultant table. So you know the composite length, we don't know how they achieved it or why, and here's some stats. But we haven't got any raw stats in this report to see what impact it actually had on the CV anyway. So not very transparent, a lot of assumptions being made. So a different way to answer this question would be to show it visually, what you've actually changed. So I wouldn't actually put this side of thing in a report, but this would be a good discussion point for people to be asking. So you can see this is the raw data. This is some channel samples that have been taken in the gold deposit. So on the trace is the gold grade, and it might be a bit unclear, but the length of the sample is just off the trace. So there's a histogram on the right-hand side for the raw data. The average sample length is about 0.6, the minimum sample length about 0.1, and the max about 2.3. So it's quite mixed. And you can see that the reason it is quite mixed is because you've got a lot of variability in the gold grade, both across the ore body and also along strike. So they obviously thought it was geologically justified to have quite small sample lengths. So we ended up going with a 0.5 because even though we have quite high frequency of around 0.3 and around 1, if we had gone with all 1 meter composited samples, we would have been removing the variability, the inherent variability that's been captured in the sampling. And if we went the other way, we risked doing some decompositing. So we went with that. And then we played around with the different mode. So the mode is a function in the compdh command. And basically, it can give you either a best fit composite or you can have residuals. And then you can decide what to do with those residual samples. So here the mode of mode of 0 has a histogram on the right-hand side. Most of the samples have been squished into a 0.5 length, and we have a few residuals, and they've been allowed to be in there because my minimum comp length is 0.1. Now, you can run all sorts of tests on this, the material impact that's going to have, and this can be a really good way to show that visually the impact. And if you do a mode of 1, you can see that those residuals have gone, and particularly on the left-hand side here, you can see that the samples have been more forced to be as close to the 0.5 as possible. So lots more decimal places. That's the quickest way to check if a mode 1 is being used, compdh, and that histogram has been tightened up. So you can do these tests and you can say, okay, it had no material impact, but we tested it. So, at least we've done the work. Here's the transparency. So question 2. What evidence was used to apply top cuts? So this can be a controversial one amongst resource geos, top cut, what's an outlier. But at the end of the day, being transparent about what you've done is the best way. So here's an example from a report, and sorry. So you can see at the top, they've outlined all of the things they've reviewed to come to their conclusion, histograms and probability plots and all this, but there's no examples of it. You know, maybe they're in the appendix. I couldn't find them. So you do all this work. You want to show it. So they've also given a table with some stats, but they've only given the cut CV, not the uncut CV. So we can't even see what impact that actually had either. Also, some software, not supervisor or data mine, but some software you can end up with some very, very, very small fonts. So make sure your figures are legible. You're going to put a figure in, make sure someone can actually read it. So here's a way you could answer this question in a resource report. So this has been shown a couple of times. So this is the global top cut analysis, which is awesome. So you see all your different pieces of evidence, and on the right-hand side, you can see the impact with the statistics and also the metal cut as well. This is a good example about also seeing that just because you have a low CV of 1, almost 1, doesn't mean you don't have outliers as well. So you've got to gather all bits of information. This is for a quite high-grade copper domain. So looking at this, I would suggest potentially a top cut of around 8. So let's see where that looks spatially, because you could be cutting away a lot of outliers, but unless you're looking at them spatially, you're not going to know, actually, maybe you've got a subdomain high grade. Maybe they're all sitting together clustered. You want to make sure you always check things visually. So you can see here, the red is 2 to 8% copper, so it's scattered around reasonably well. You can't really see the pink, which is what I'm suggesting with top cap. You zoom in, there it is. So it's going to be immaterial to the metal, but we also don't want that 11% copper floating around. So comfortable, we've got all that information, nice and clear, we can top cut that. Question 3. So what information was used to justify the variogram model? The variography can be a tricky one for non-resource geologists. It can be a bit of a scary one to kind of question the resource geo on, but geologists are very good at comprehending things in 3D. So the best thing you can do is create an ellipse, create a 3D ellipse of your variogram, compare to the data. Anyone can say, hey, that looks right. It's also a really good way to check that your major direction is your major direction. So you can see here, they've got lots of text and lots of verbiage about variography. The only people that are going to understand it are resource geos, and they don't need to be told what a variogram is. No non-resource geos are going to have no idea. So you want to be nice and clear what you've actually done, and visual is probably best with variography. You also want to make sure you've got all the information that you can on your variogram. So pairs, nice and clear what domain you're looking at. This particular variogram as well had a 95% variance within the first 2.5 meters. So I would suggest it's probably not suitable for variography anyway. So here's an example, visually what you can do. Now I'm not suggesting you put every variogram in your resource reports. For some deposits that it's going to be ridiculous, but you should be storing them in your appendices for sure. So here's the major direction, so you can see the number of pairs, you can see the ranges, and then you can see the back transform model. We've got a major, semi-major, and minor, and then you've got a model ellipse, which matches well with the domain. So visually, anyone can look at that and go, yeah, that makes sense. Maybe make the plunge a little bit steeper. You can go back to the geology, see what actually makes sense. You've also got a nice clear table with a calculated nugget. No one has to go figuring out what the nugget is, and your rotation angle. So anyone can reproduce your variogram model based on that information. So question 4, how does the block model correlate to input data? Now, even a resource geo can look at coloured drill holes over a block model that's coloured the same legend and decide whether it's probably a bit, So let's not insult people, but lots of features in your resource report. Make it nice and clear that you've done a really good job and you've represented the data. Here's an example of what not to do. So you can barely see the grades on the traces. They've exacerbated the 5 gram plus material, but then none of that is represented in the block model. So it's very smeared. They've ignored the plunge. It's really, really hard to see what's going on. There's also a lot of subjective text. Now, a resource report is a technical report. It is a scientific report. be a scientist. What is a good correlation? You know, it's very subjective. But one person thinks it's a good correlation, another person might think it's terrible. Also, what's too far? Who knows? That's different for different deposits. So you want to avoid subjective language. You want to be nice and clear and give as much quantified answers as possible. So here's some examples of what you could do. Again, lots of pretty pictures. I deliberately left this gold legend off. But this one, you can clearly see that the composites that are coloured the same grey as the model, they match reasonably well. You know, the grade isn't spreading around. You can clearly see what kind of trend is present as well. You can also show the pass number. So you can see how much confidence we have in the continuity of the mineralization. Here's the slope of progression, which can be really helpful to show confidence in the model, that it's conditionally biased, as well as correlation with the pass number as well. So you can see, you know, what we'll be searching to, what percentage of the variant ranges we'll be using. So you can also see in this one, the composites are slightly different colours. And I know for this one, this is because they've been coded using a data class, so that's the qualification of composites. How much confidence do we have in them? So here, the green is slightly less confident in the data. So the rescats are on there as well. And you can see that even though we have quite good close space data up the top, clearly that's been assigned a lower confidence, probably because it was historic RC or something like that. So while it's fine to use it in the model, they don't want to include it in the indicators. So that's a good way to show that impact quite clearly. Also, lots of swap plots. Doesn't work for every deposit type, but it definitely works for something like this. You've got all your different estimation techniques that you've got on there, so you can show what's been tested, what you decided to go with, as we clustered composites as well. And that's the other one, declustering. Everyone talks about declustering. Very rarely do we actually show a declustering graph or something like that. Particularly when you have a domain that, you know, visually you can sort of see in the resource report that you've got mixed spacing, and then there's a assumed declustering window. You want to prove what you're using is actually reasonable. And then global stats. Global stats are great, and they should be in there, but they should be taken with a grain of salt. A model can be overcalling at one end and overcalling at the other, and then they balance each other out. So you've got a within 5% global stats. Doesn't mean your model is actually representative. So the visual component is the most important. Everything else is just extra evidence. And the last question you could ask, what information has been used to inform the resource classification? Now, you'll normally get a list of you know, variables that have been thought of, which is great, you know, grade continuity, data spacing, you know, estimation, performance, all that kind of thing. And then you might get something like, you know, as required for JORC compliance. Okay, let's check JORC table 1. What does that say? Same factors, and then whether it reflects the competent person's view of the deposit. So let's go straight back to what we've actually just said. As CP, we need to be able to defend what you've decided. You can't just say, oh yeah, it's in the code. It's not in the code. It's deliberately not in the code. So you've got to be very, very clear with what you've actually used to determine resource classification, because people will ask you. Like this example on the left, you know, it's not compared to any drill hole data, so we have no idea what the spacing is. We haven't got any other information on the quality of the estimate, so not very transparent. What you can use instead is, yes, again, you know, these are the factors that we've looked at, including confidence in the data as well. That's an important one, but it's been much more explicit. So measured within, you know, 15 meters of ore development, indicated spacing, relevant to the slope of progression, and this should obviously all be deposit specific as well. Having a picture of the slope of regression in the model is always helpful, and then the block model coded with the rescats with the data compared to it as well. Can be always helpful to have depleted blocks shown too, as well as any potential mine design. So it just gives the whole picture to the engineers who are ultimately going to have to take this model and put a reserve on it, hopefully. So in a nutshell, question everything, and don't be afraid to question resource geologists. We're not that scary. More pictures and less words. Pictures, you know, it's cliche, but a picture says 1,000 words. So more pictures and resource reports are better, I think. The only limit to a resource estimate is the resource geo's imagination. This is the, the art side of the art and science that Jackie Coombs talked about. And it's the best part of being a resource geo. It's the funnest part as well. But we're just going to make sure that we're being transparent in all these assumptions that we're making. So make sure you stay up to date with things like this, which is great. Thanks to Dynamite for putting it on. But stay up to date with people on LinkedIn. Scott Dunham's blogs are great. Renee Sturck's got some really good stuff on LinkedIn as well. So just keep having these discussions. And continual improvement is the aim for everybody. So yeah, that's it.